This video is meant for homework for September 21st, September 22nd. We're looking at the graphs of secant and cosecant. Hopefully we can notice something about these functions and how to graph them. I'm going to talk about secant function, and hopefully we can see the relationship between secant and its reciprocal function. Again, remember secant, its reciprocal is cosine. And if we're talking about cosecant, its reciprocal is sine. Hopefully we see a relationship with that today in terms of these graphs. That's the goal. That's the goal we're doing today. And so what we can do is we can graph the secant function using the function, let's call it g of x equals cosine x. Let's see how we can do that. So for example here, if I have secant of x and I want to find it for all of these x values, if you want to pause and so you can write down these x values, that might be good. But we can go ahead, I'm going to try to do this. If I look at cosine of negative pi over 2, it might be good to have your unit circle out as well. That might be a good thing to have. But negative pi over 2, if I go pi over 2 this way, then negative pi over 2 would be down and coterminal with 3 pi over 2. Cosine of negative pi over 2 is 0, which means that secant of negative pi over 2, I take the reciprocal of 0, and that would be undefined. Because if you think about it, I could rewrite if 0 here, and the reciprocal, I can put that 1 over that value. The reciprocal of 0 is 1 over 0. That's going to be undefined every single time. So the secant of negative pi over 2, that's going to be negative or undefined. If I do cosine at negative pi over 3, negative pi over 3 is going to be coterminal with 5 pi over 3. If I go pi over 3 this way, negative pi over 3 this way. And that's going to be 1/2. Which means that secant of negative pi over 3, if I take the reciprocal of 1/2, I would get 2 over 1, which is just 2. And we could do this for all these values. Cosine of 0, that's going to be 1. The reciprocal of 1 is just 1. Again, on the unit circle, cosine of pi over 3 is 1/2. If I take the reciprocal of 1/2, that would be 2 over 1, which is just 2. And cosine at pi over 2 would be 0. And again, the reciprocal of 0 would be undefined. So where are these values coming from? I'm plugging in these values from the unit circle. You can plug in negative pi over 2 to get 0. Negative pi over 3 to get 1/2. 0, 1. Once I do that, then we can take the reciprocal. Again, the reciprocal of 0, similar to what's happening here, is going to be undefined. The reciprocal of 1/2 would be 2. The reciprocal of 1 is still just 1, and so on. So we don't care about these. Don't cross these out, but we don't care about this. We're just using cosine to figure out the values of secant. These are the pieces that we want. This here, the secant values are what we want. And that's what we're going to use to graph this function. Now I'm going to still go out to 2 pi, and we'll see eventually why that's the case. However, on the y-axis, I'm going to say let's go 1, 2, 3 just for this case. So that'd be -1, -2, -3. I'm also, so we can see a relationship. Hopefully we can see a relationship here in a second. I'm going to draw the cosine parent function on here as well. So again, cosine parent function starts here at 0, 1, 0, 0, negative 1, 0, 1. So this is my, or our, I guess, cosine parent function. So we have this so far. We have the cosine parent function, x and y scale. Now I'm going to start putting on the values. Let's just work our way here and work our way down. At negative pi over 2, so that would be here. This is negative pi over 2. It's going to be undefined. Hopefully remember from tangent, if it's an undefined point, we can denote that by doing a vertical dotted line saying it's undefined here. In fact, I'm going to do this in blue because it is a different function than our parent function cosine, or our function cosine. Now, negative pi over 3. Negative pi over 3 is going to be close to negative pi over 2, but not quite. So around here, and its value is going to be 2. 0, comma 1, so 0, 1, so I'm still touching there. Pi over 3, comma 2, so pi over 3, let's call it here, and it's going to go up to 2. And then pi over 2 undefined, so another vertical dotted line here at pi over 2. Now what's happening here is you cannot notice as it's 2, it goes down to 1 and then goes back up to 2. So this function actually is going to have like this U shape, almost like a parabola right there. And it's undefined here. What's happening is as this line gets closer, as we get closer and closer to pi over 2, this line is going to get really, 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 really close but never touch. This line is going to get really, 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 really close but never touch. And so we have this parabola, or this U shape, that is like squeezed within these dotted lines. It's never going to like go outside. These lines are going to get really, 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 really close to the dotted line but never touch. Really, 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 really close to the dotted line but never touch. And that's what's happening here in this little section. Now, if we continue, if you need to pause, rewind, that's fine. Please do so. Now, if we continue in this direction, let's just start with the zeros. At negative 3 pi over 2, cosine is 0. It's touching the x-axis. But we said the reciprocal of 0 is 1 over 0, which is undefined. So here at 0, the function is going to be undefined. 3 pi over 2, it touches the x-axis, is going to be undefined. Now it's just a matter of what's happening in between these dotted lines. Are we going to have an upwards U? Is it going to be something else? And what's actually happening, like here, it takes, the cosine function takes this shape and it takes this shape again. So we can actually, you know, at 1, at negative 2 pi, the function's value is 1. What's the cosine function's value is 1. What's the reciprocal of 1? It's 1. Same thing here. So our cosecant, or our secant function, is going to hit these points because the reciprocal of 1 is 1. And then it's actually going to take this almost exact same shape. It's going to do this U shape here. Because think about it. At pi over 3, cosine is 1/2. It's also going to be 1/2 here, which means it's going to be 2 here. And there. And a similar thing over here. Now, what about what's happening down here? Well, the reciprocal, if you would look at negative pi, cosine's value is -1. The reciprocal of -1 would be -1. And then let's say this is -1/2. Well, cosine is negative 1/2 here, which means that it's going to be the reciprocal of negative 1/2 is negative 2. Cosine is going to be negative 1/2 again here. The reciprocal of 1/2 is negative 2. And so this is our secant function. So our secant function has a lot of different uses. It's the reciprocal of cosine. We can actually use the graph of cosine to graph secant. I want us to be thinking that way. You don't need to describe it yet, but we can use the graph of cosine to be actually graph the graph of secant, our parent function for secant. Leave that here. We're going to talk more about in class the key features, what makes it unique, and how exactly we can use cosine to graph the graph of secant.